Okay, I'm gonna go ahead and start. And what we start out with this one is managing VLANs on Cisco switches. We talked about VLANs in ICND1, and the VLAN was the way to break up a switch into broadcast domains. If we put machines on a switch with different IP subnets, they'd be isolated from each other. You wouldn't be able to contact a 192.168.1 network from a 192.168.2 device. You'd still need a router to do that. But what we would have is a number of broadcast domains. And we usually say a switch has a single broadcast domain, but if we had different IP subnets on it, we'd have multiple broadcast domains. And that's what we're trying to eliminate with the VLAN. So the major topics of this one: configure VLANs on Cisco switches, and they're not really that difficult to configure. Just go into the config and VLAN, whatever number we want it to be. Configure connectivity between Cisco switches, and we're going to be talking about trunk ports, which we talked about the last time. Troubleshoot VLANs. Typically, the troubleshoot VLANs is we've got the device on the wrong VLAN. We've got a wrong IP address. If we're trying to go from one to the other, we didn't, supposing we're using a router on a stick, we didn't associate the VLANs properly. Number of different things that can happen there. And then troubleshoot inter-switch connectivity are the things we want to talk about. And these are some of the I've added kind of things. So in switches, each segment has its own collision domain, and that's the big advantage of switches. Is each segment, each of the ports in a switch is its own collision domain, but the entire switch is one giant broadcast domain. If we have a 24 port switch, then we have a broadcast domain, a single broadcast domain with 24 devices in it, perhaps. Or again, if we had several different IP subnets on it, we would have a number of broadcast domains. What we're trying to do is eliminate or isolate broadcast traffic as well as communication between these things, or visibility between the devices themselves. The flat network structure, here we have every broadcast packet is seen by every device. So again, however many switches we have still a single, we'll call it a single broadcast domain in these things. So every broadcast packet, but only the broadcast packets, are seen by every device, regardless of whether it needs to receive the data or not. But broadcast, we would presume it needed to. But what happens eventually, and if you've ever looked at any information on a Microsoft network, Microsoft machines can't not broadcast. They're really crazy about that. Switch network, in these things, switch network shows host A sending a frame to host D to its destination. We had the MAC address table, and the MAC address table allowed us to send it to the individual device without sending it to all the other devices after the first transmission. The first time through, when it doesn't have an entry in the MAC address table, then it floods it out all of the ports except the port that it came in of. And this one says the network shows host A sending a frame with host D as its destination. The important factor here is that the frame is only forwarded out the port where host D is located in this thing. And the other one coming back in and out, how does it know where it's located? The MAC address table will tell us that. One switch, one LAN. Before VLANs, virtual local area network, there was no separation between hosts, and what this one shows is we can create the VLANs and sales, and we can name them, number of them, name them, sales and admin. And one of the things when you start creating VLANs, just me, if you have a 192.168.10 network, make it VLAN 10, because if you make the numbers similar to the networks and the whole thing down the line, then it's easier when you start working on these things. And it's really easy to get them kind of confused when you have a number of VLANs, number of devices all working at the same time. We can name them. Names are good. One of the things, and this says sales and admin, if I don't have anything really particular like that, if I had a classroom, for instance, I might, if I had a classroom 200, I might make it 192, 168, 200, and I might make the VLAN the 192, 168, 200 VLAN so that I can do all of those associations easily when I start working with the devices. The VLAN basics here, why do we do them? Enhances security, it creates broadcast domains, divides the network into smaller logical networks, which is going to give us the smaller broadcast domains, not as much broadcast traffic, and lower susceptibility to broadcast storms. And you can get a broadcast storm can happen at layer 2 because layer 2 has no mechanism to stop traffic. Layer 3 does. We have a time to live for all of the IP packets so that they'll eventually die en route, die on the internet, and they won't go forever. A layer 2 device can go forever, and that's where a broadcast storm comes in. It doesn't know where it is, goes out all the ports except the one it came in on, and then it comes in on another one, and it just goes around and around and around and continues to build until it shuts down the network. And this one switch, 2 virtual LANs, logical separation between hosts. What this is showing in image form is the same thing that we had back here, except to illustrate that we do have 2 broadcast domains. They've drawn 2 switches here. Still physically 1 switch, but it acts as many separate devices. We can have multiple VLANs. How many depends upon the device itself. All of the devices have different capabilities. It says I configured the switch to be 2 separate LANs, 2 subnets, 2 broadcast domains, 2 VLANs. They all mean the same thing without buying another switch. So we can buy another switch, or we can create the VLANs. When would you want to do this? And I think one of the examples that I talked about in the last class is in a physical classroom. You come in, and we used to have a student network and we had a faculty network. Well, when the faculty went into the classroom, they were on the student network. There were some restrictions getting back to the faculty network, so you couldn't always get the resources that you needed. What would be a solution to that? Golly, we could go in and create VLANs, faculty VLAN, student VLAN, admin VLAN, medical VLAN, because we had medical in there also. And we could then go into the classroom and put the port that the instructor machine was on in the instructor VLAN. They can get all of their resources. They're isolated from the students at that point. So just different ways. This is where the slides that were provided to you, and again in that the CCNA LDC the PowerPoints that I'm using are there, and I'm actually just sharing the folder that they're in. So VLANs, a LAN in which a network components can be connected even when they're not on the same LAN segment. What does that mean? A LAN in which, I like to scratch too, which network components can be connected even when they're not on the same LAN segment. So we have VLANs here, and we have this special thing called a trunk port, which is kind of omitted here, that says a LAN in which the network components, the marketing VLAN, this could be like different floors of a building, the first, second, third, and fourth floor of these things. They can all talk to each other as long as we have a trunk port in here somewhere, because a trunk port, and we're going to talk about the types, we have trunk ports and access ports. Trunk port allows us to go from one switch to the other with our VLANs. A logical network without the physical characteristics of a logical network, we go into the config and type VLAN 30 and we create the VLAN. We create that logical entity that separates it from the other parts of the switch. By default, we have a single VLAN, VLAN 1, and all of the ports are on VLAN 1. Once we create the VLANs, we obviously have to assign ports to it, the ports that are all going to be communicating with each other. Each VLAN is logically a network in itself, and if there are packets that are not meant for the node that does not belong to the same VLAN as the source node, they must be forwarded by a routing device. Boy, that's a mouthful. It says that if we have a whole bunch of different IP networks, IP subnets, we got to use a router to communicate, for them to communicate with each other. Router on a stick, where we make this a trunk port and use the .1Q encapsulation. These are all terms that should come back from ICND1. So, and then we have sub interfaces so that we can route between the IP subnets that we've created as VLANs. Am I making a mess out of it, or is it okay? So VLANs themselves, normal VLANs, the normal VLAN ranges, and these are kind of questions that are easy multiple choice questions. VLAN 1 to 1005, 1 and 1002 to 1005 are automatically created and cannot be removed. They're there. These are the 1002 to 1005 are like token ring and a number of other ones. Well, I'll get a switch up here in just a second. When a switch is a VTP server or a VTP transparent mode, you can add, modify, or remove configurations. And VLAN trunking protocol, we kind of just jump into it. The configuration for VLANs ID 1 to 1005 are written to the VLAN database, and the privileged exec mode show VLAN can be used for the configuration. I think that what I would like to do then is let's look at some of this stuff. Yeah. Let me start my packet tracer here and get over here. And I have some VLAN stuff in here, I think. Let's see. I think this is the one. I've forgotten which one I wanted to use. No, it wasn't that one. What I want to do is to look at these things. I could actually set it up pretty easily. I keep getting the wrong one, the same wrong one, don't I? Open. Let's try VLAN demo. Yeah, this is better. This is better. This has got some configurations here. Let me turn off the labels. I can figure out where they are. Show incline, show. Always show port labels because they kind of get in the way. What we can do here, show VTP status, tells us that we have a server. And what I want to do here, I think, is to maybe do these because I use these for other ones, is to go in here and show BTP status, and it's a server, and we have a operating mode's a server, and then we have a domain name ICND. We have to configure these things. By default they don't have the domain name, which allows us to do those things. So if we go into this other one here, status, and this one is in transparent mode. Good. Transparent mode. So let me add another switch here, and we'll put it, I wanted to get to my switch, put a new switch in here, and we'll use the crossover cable and wake up. So these ambers here is spanning tree protocol, which we will get to when we do these things. We can show BTP status, and this one is a server. So config, actually type too fast, and I think VTP, yeah, VTP and a question mark. And by the way, when you do the certification test, when the things where you actually have to do configurations, the question mark works. So we can do mode, and on this one let's make it a client, and we'll do an end, and let's see if we can make, because this is one of the things that VLAN 33, and this says that configuration is not allowed in client mode, so we can't do it. We can't make VLANs, create VLANs if it's in client mode. Let's see, it's VTP status, and we don't have a domain name, so let's do config T VTP. Domain was ICND, I think. So now do show VTP mode. Status, not mode. So we are ICND, we're client. Number of existing VLANs are 5, and if we go here, just what it said, and show VLAN, then we have 1 is the default, the 1002 to 1005, the FDDI, the token ring, FDDI net, TRNet. These are ones that are there. They're not used anymore, but they do exist in these things. So we have them there. We can't do anything about them, and we're on a client, and we can't make a VLAN. We can't create a VLAN. So we go up here to the server, and this should be the server. If we look at the VTP status, it is the server. We can go in here and big T and then create VLAN 33. So with any luck, if these things are actually working, when I go back down here and do a show VLAN, and sometimes they work for me and sometimes they don't, and it didn't this time. VLAN 33 should have been sent to this device. It's not. It's making me out a liar again. But when we create them on the and maybe because I hadn't configured it yet, on the VLAN 33 on the router, on the server, it should send it to, and it still didn't, it should send it to the client. We'll get it going here in a minute. If you do a transparent mode, it relays the information. In transparent mode, we can create them. Config T VLAN 34, we don't want it to be the same. And we do a show VLAN, and we have 33 and 34. Well, it's not supposed to take it. So this is a good example of how it's not supposed to work. I'll probably have to do some devices already in transparent mode. Okay. So now that the simulator didn't work right, what is supposed to happen, and I will, when we take a break here in a few minutes, see what the heck's going on with this thing. And it usually is that it's saved and it's running and it's not running. It's just something in the simulator itself causes these things. So what's supposed to happen and what did happen are not the same thing. But privilege exec mode show VLAN to display the VLAN configurations of those things. We do have extended range VLANs. We can go up to 1006 to 4094 if the switch supports extended VLANs. And then a couple of requirements here. The switch must be set to VTP transparent mode using the VTP mode transparent command for versions 1 and 2 of the VLAN trunking protocol. Not stored in the VLAN database or stored in the running configuration file. Extended range VLANs enable us to extend their infrastructure to reach a greater number of customers. And they're talking about for the service providers. What a lot of times they'll do, and we're going to look at what these things, got an image here that we're going to use an isolated VLAN in order to isolate us from our neighbors. So the extended range service providers to extend the infrastructure are allowed for any switch port commands that allow the IDs. Privilege exec mode copy running to startup allows you to save the configuration. Extended range are supported in VTP version 3. Server and transparent modes are stored in the VLAN database. So in the later versions, they are in the VLAN database. Prerequisites to configure these things. The reduced MAC address feature is required to support 4,000 VLANs. What they're saying here is if we go with the extended VLAN, then we're going to reduce the number of MAC addresses that we can record on the switch. Spanning tree uses the extended system ID to make the bridge ID unique for each VLAN. Without the reduced MAC set, 4096 would require 4096 MAC addresses for these things. So spanning tree, which we haven't talked about yet, but will, uses the ID plus the MAC address to make the bridge ID unique for each VLAN. So we're going to have bridge IDs instead of MAC addresses for these things. The extended feature must be enabled, and then for information on it, go to Cisco. Not all of the switches will allow this to happen. So you have to have a switch that supports it when we do those things. Multiple switches, regular VLANs and private VLANs can span multiple switches, and we haven't really talked about that. I want to go to the next slide first and then come back to this. We have private VLANs. We have a number of different VLANs that are available to us. Richie's having a kind of a come and go here. We have promiscuous, and it's basically a port, and we have secondary VLANs. We have isolated VLANs and community VLANs. The isolated VLANs is kind of what the ISPs do for us to keep us isolated from our neighbors. I remember when the first time that I got a high-speed internet, you can see everybody in your neighborhood. Now you can't do that. So in an isolated, the isolated can talk to itself, and it can talk to the promiscuous port, which means it can talk to the router. The community ports down here can talk to all of the devices that are in the community and to the promiscuous port. So isolated ports, isolated, community, and promiscuous are all part of the private VLAN structure. And I will go back to this one. Both regular VLANs and private VLANs can span multiple switches. ISL inter switch link ports need not be aware of the special VLAN type. They don't really care. Because what we're really talking about here is layer 2. Layer 2, yeah, we can do a lot of things at it. We isolate it at layer 2, but then we use layer 3 to communicate from one to the other. Carry frames tagged with these VLANs just like any other frame type. So it doesn't care if it's a private or a community or whatever. It just knows the VLAN number, and it's got the VLAN tag, and it knows if it's a trunk port, it can get in the trunk port, and then it's got to go to the layer 3 device to communicate between the things unless they're on the same VLAN, the same network. Consistent behavior throughout the network can be maintained by embedding the isolation information at the VLAN level and transporting it along with the packet. So what we're going to do is put it into the layer 2 frame. Layer 2 communications between two isolated ports in the same switch restricts the layer 2 communication between two isolated ports in any two different switches. So again, isolated ports. And this is a not, I guess, simple. It's not that complicated, but first you got to create the private VLAN, and then you create the VLAN types. Isolated VLANs, again, can talk to the promiscuous port, only the promiscuous port, which means we have to have a promiscuous port or promiscuous VLAN in order for these things to work. The community, in the community VLANs, they can talk within the community and to the promiscuous port. So if we're going to go from one of these secondary VLANs, the primary VLAN, and within the primary VLAN we have the secondaries, go from A to B, we've got to go through the router. Isolated is in fact isolated. And a number of things. I think Microsoft now allows you to enable a configuration in servers that make them isolated, that they become an isolated port. You have to go through a router to get to them. Access ports, and we have, again, we've talked about, and we talked about them in ICND1, the access ports and the trunk ports on these things, and we configure a switch as an access port and assign it to one VLAN. If we go into the switch port mode access, and we can do it for a range of addresses, and I will go back to still make a mess out of myself, and we can go into let's do show IP interface. Well, they're all up here, and you notice that they all are listed except gig 02. Gig 02 is going to be a trunk port. If we wanted to show interface trunk to see which are trunk ports on these things, but right now, if we want to make these things access ports, we can go to the config T, and go to interface, and I'll do a range FA0/1 to, let's say, 12, which gives me a range, and then I can do what is it? Switch port mode access. Switch port mode access, and then we can access ACC access VLAN, I hope 33. So we create these things. I guess that I'm. Oh yeah. Come on, access. Switch port access. Switch port access VLAN 33. Okay. So we can show VLAN again. And now we put those ports on VLAN 33. So and you've done that done that in the other labs, but a quick way: configure a switched port as an access. It can be a member of one and only one VLAN. Speed and duplex for auto negotiate is the default, and there's no reason to make it anything other than auto negotiate. Allow it to negotiate the speed and the duplex automatically. Includes the auto MDI/MDIX feature if the switch supports that. What does that mean? On our home routers, our home switches, you can plug in any cable straight through or crossover and it will automatically configure itself, and that's what the auto MDI/MDIX feature is. Auto straight through and crossover MDIX. It's going to give you, if you plug a straight through in and it needs a crossover, then it'll configure itself physically in the port to do that. Eliminates the need for crossover cabling. You may not find that feature in all of your switches though. Can't disable the auto MDI/MDIX for an interface, which means it's always going to be enabled. Cisco hadn't used that for a lot of years, but everybody else, this is one that they didn't lead on. They as well as being able to GUI interfaces, they stayed with the command line, and CCNA, ICND is all command line. Access the data port. When you define a data port, you must consider the following: the slot port combination. That's like fast FA01, fast Ethernet 01, 020, whatever. The 0 is the slot, and then the number is the port number of these things. Define the VLANs that are to be forwarded to the data port, which is what I finally got the command right. But to create it and then add the port to the VLANs with the switch port access when we're going to access the VLAN. So we create the VLAN and then we add the ports to the VLANs. Following restrictions, there can only be a single definition for each data port, one access port per, an access port can be on a single VLAN. Cannot be created if the port is already defined as part of a channel group. We haven't talked about channel groups yet, but we will. Channel group is when we combine a number of ports and treat them as a single entity. So we will treat them in a special way. So I've been going, and we're getting ready to identifying VLANs, access, and trunk links when we look at those things. Let's go ahead and take a break until about 5 minutes past the hour. Let me see if I can figure out why this other thing, why my simulator decided to simulate me out of business. Do earlier. So this is the client. We made it on the server, and if we do a show VLAN, we have our 200 VTP demo Monday, which we created on the server machine. So after it made me look silly, it did work this time. So what we now identifying VLANs, access links that can only be on one VLAN, and a trunk link which carries multiple VLANs. Trunk link carries the information for all of the VLANs unless we do pruning, which means that it's not at an end or something, and we don't send the information there. So trunk carries multiple VLANs. Access ports, and this is just imaging, I guess. An access port belongs to or carries the traffic on only one VLAN, and we can say that time and time and time again, and do say that time and time and time again. But one VLAN, traffic is both received and sent in native formats with no VLAN information tagging whatsoever. Traffic is both anything arriving on the port, and what that means is what we have is they're all on the same broadcast network. So we have these things on the same VLAN, there's no need to tag them. They're all associated together into a VLAN. They're all in a broadcast domain. So they send information back and forth. When we send it across the trunk port, when we have multiple VLANs, if we had, now let's try this again. We have VLAN 1 here and 2 here, and VLAN 1 here and 2 here. When the traffic goes out on VLAN 1, it has to be tagged with VLAN 1. When it gets in here, the tag is stripped off and that information sent to VLAN 1. So if we are just communicating on a single switch in a single VLAN, we don't need any tags. So no VLAN information tagging. Anything arriving on an access port is simply assumed to belong to the VLAN assigned to that port, because when we created the VLANs, we then went to the switch port command and accessed the VLAN with those ports. So they are all there together. They share the information. Because an access port doesn't look at the source address, tagged traffic, a frame added to the VLAN information can be correctly forwarded and received only on trunk ports. So tagged traffic, trunk ports, and that's where we add our .1Q information in order to put the tags, the encapsulation protocol, to tag the information that goes across them. Access voice port. The voice port is kind of throws a wrench into this one, because if we have a voice VLAN, it can appear on an access port, will appear on an access port as well as the data. And what this shows is the Cisco IP phone switch. What we would do here is then plug in the computer to the switch. What happens is if we are on a VLAN on this port, let's say we're on VLAN 20, the Cisco phone sends the frame through it to this port. It then becomes part of VLAN 20. The IP phone puts the voice data on a separate VLAN. So it tags the information for the voice VLAN, whereas the switch would tag the information for the data itself. So the voice VLAN, when the switch is connected, the phone sends the voice traffic with the layer 3 IP presence, layer 2 class of service. We'll talk about those when we do some QoS. What this is saying, if it's layer 3, it's the same thing. We're going to prioritize traffic. We can prioritize it at layer 3 or at layer 2. It's called class of service at layer 2 and a precedence at layer 3.
Larry, what does that configuration look like on the Cisco switch there where you wrote 20? Is that a trunk port, or is that?
No, it's an access port. This is the only time that an access port can have 2 VLAN numbers on it.
So you can do a port fast on it and it'll issue the IP without checking whether it's connected to another switch or not?
Yeah. What we do is, if we have a voice VLAN and we have to give the voice VLAN command, voice VLAN, then the voice traffic goes on the voice VLAN and the data traffic goes on the data VLAN. The way that happens is the computer gets connected to the phone and the phone just sends its traffic to the data port, and the data port says, oh, I'm VLAN 20, so if I'm going to tag it, I'm going to tag this traffic as VLAN 20. It sends the voice traffic to the voice VLAN, and it gets tagged with whatever it is, 50 or 30 or 16, whatever the voice VLAN number is. Does that make any sense? But these are access ports. Okay?
Okay.
Yeah. Always ask those questions a lot. Default VLAN 1, we saw when I did the show VLAN, which was the one thing that did work in the packet tracer the first time around. The default VLAN 1, which uses only default values, doesn't allow you to create, delete, suspend activity in the default VLAN. It's there. We can't make it go away. We can't delete it. We can take all of the ports off of it and put them on other VLANs, but it is the default VLAN 1, and so it's going to be there for forever. VLANs can be assigned from 1 to 4094 if we have the extended range VLAN, and you should probably numbers, you should know both of those. All configured ports belong to the default VLAN when we first bring up the switch, and we saw that with the go back to the packet tracer here. We'll go over here, we'll bring in a new switch, maybe. A new switch here. Nothing magic about it. It's starting up. The pound sign says that we are decompressing the iOS with this thing. So show VLAN, and all of my ports are on VLAN 1, including the gig ports. Well, I'm not going to have any trunk ports yet. We don't need any trunk ports yet. We're not connected to anything. We haven't created any VLANs. That's the only time that we need trunk ports. But everything is on VLAN 1. The default VLAN is going to be there. And when we look down here, 1002 to 1005, so we can go to 1005, but 1002 to 1005 are pre-configured. So the VLANs that we can create are between 2 and 1001 when we do those. Add and remove VLANs. You need to use the VLAN ID to create a new VLAN. We did that packet tracer. Cannot create or delete the default VLAN and other VLANs that are already the 1002, 3, 4, and 5. We can't do anything with them. Can create a VLAN. When you create, it's automatically in the active state, but it doesn't have any of the ports assigned to it. We have to go back and assign the ports separately, and we can assign them in a range. The interface fast Ethernet interface range, and I always do this, interface fast Ethernet 01-20, and it says you can't do that. It's interface range. We can use a range of interfaces and assign them all at the same time. The no VLAN, to delete the VLAN. When a VLAN is deleted, the ports associated will be shut down. And let me go back and let's look at what that means. We did some, which one did we put ports on this one? We can do it anyway. Show VLAN, got to be able to type. So if I go in here and do a config T and do a no VLAN 33 and do a show, and it's got fast 1 to 12 on it, show VLAN. I don't have those ports anymore. They're gone away. They're in a black hole. If I create VLAN 33 again, VLAN 33, to show VLAN, too quick. Show VLAN, then they come back. If we're going to make a VLAN go away, first thing we need to do is remove the ports and then delete the VLAN so that we don't get into that situation. Go ahead. Did you have something, Joel?
I thought I did, but I'm not sure. Um, it's more like the whole token ring network. I imagine there's a device that you got to put in between that and an Ethernet in order to talk to each other.
Yeah, these are just there. They are not used anymore. And if you read
Oh,
any of the
really?
literature, they're there. They just never did away with them.
But
And
there's still, I think there's still token ring
there's still
that
token
network.
ring, but you have to have a multi-access unit in order for it to work.
Okay, that's what I was.
Okay?
Yeah.
MAU, multi-access unit, in order to connect the token ring stuff together. Is that the thing that was perplexing you?
Yeah, in a way, because I do have a network that uses token ring,
Yeah,
but we talk to the server through an Ethernet,
yeah,
and so there's some devices in between the token ring and the
yeah,
server that
yeah,
collect it.
yeah. But they connect to an MAU, I think, don't they?
I don't know what they call it. It's
Yeah,
proprietary stuff, but
yeah. That's why a lot of people don't use token ring anymore. Proprietary, IBM owns it. Multiple switches, VLANs, or yeah, trunk ports. Uh, is that in all of those, whatever speed, and we should use the highest speed port as a trunk port for the multi-links, the links between these things. As the data from a VLAN, the sales VLAN it's in the access port, if it needs to go off of the switch onto the trunk port, it's tagged with its VLAN number as it leaves the switch. When it gets to the other switch, that tag is stripped out and it's sent to the VLAN that was on the tag. So sales VLAN, maybe VLAN 12. When it goes to the trunk port, it's tagged as VLAN 12. When it gets to the second switch, the VLAN 12 information is stripped out because it makes it a non-standard frame, and then sent to the devices on VLAN 12 when we do that. So what it always says, between two switches, even between the switch and the server. Let me stretch this out a little bit, maybe make this a little bit easier to see. Uh, Two switches between one switch and a router, or even a switch and a server, it carries the traffic of multiple VLANs. The trunk port carries a multiple VLANs. And when we did the router on the switch, or router on a stick, we configured a gigabit port as a trunk port on the switch, and then assigned sub interfaces so that it could route between uh, these different VLANs. We will, a little bit later in this one, do what's called switch virtual interfaces using layer 3 switches and using virtual interfaces on it. Add and remove trunk VLANs on a trunk port. Switch port mode trunk command changes it into a permanent trunking mode, and we have three different things. We can have a dynamic, which can be desirable or auto, and desirable says yes, I want to be. Auto says if you ask me, I will be. Trunk, switch port mode trunk says be a trunk port. Negotiates to convert the neighboring link into a trunk port. The neighboring link is going to be, in the newer switches, are going to be auto. In the older switches, they may be desirable, which is not the best configuration. And I'm not even sure that auto is the best configuration, because it's easy to force a trunk between the switches on these things. The old switches, you connected them together and they automatically became a trunk. The new ones, if you do an auto to an auto, and I'll have a table here in a little bit, an auto to an auto, they won't do that. But if you auto configuration says that if you ask me, I will become a trunk. And when you do the switch port mode trunk command, then it will tell it to become a trunk. So let's go back to this thing again, and which ones are allowed where, and which one did we have? We had several VLANs on this one, I think. Yeah, we hopefully have some show interface trunk. And if back here up here in the VLANs, uh, gig 01 we have, but gig 02 doesn't show up. If an interface doesn't show up in the show VLAN, try the show interface trunk command. And trunk ports don't show up in VLANs because they're members of multiple VLANs, or multiple VLANs transit them. Only the access ports are going to show up here. So we have this thing. Its mode is auto, which means that somebody else asked it to become one, and we'll look at the other end here in a second. But we have the VLANs allowed on the trunk, and by default it's all of them. VLANs allow port gig 02, VLANs allowed and active in the management domain 1, 3, and 122. These are the active VLANs that are in it. In the spanning tree, forwarding and not pruned. Not pruned means that, yeah, we're going to send it out. We can limit by the VLANs allowed command what is allowed and what isn't allowed. So let's see if I can mess this one up. Big T. I'm just too quick on the space bar, huh? Interface gig 0/2 switch port trunk, and then we can say allowed. And let's just do a demo here. Let's do switch port trunk allowed 33. And VLAN, you got to tap the VLAN 33, and show interface trunk. When I give that, it only allows VLAN 33. We need to do an add. So what we can now go back to this thing, since I did that to try to demonstrate that. Let's do all. You're supposed to be able to do all. Switch port trunk. Oh. Yeah, I guess if I go to the interface it will work better, huh? Switch port allowed, VLAN all. Do show interface trunk. So now we have those back. We need to use switch port trunk allowed. We need to use the add or remove. We could remove them one at a time. We could remove them all. If we wanted to add a VLAN, we need to use the add word instead of just the number. If we just type a number in there, it takes all of them away except that VLAN. No switch port trunk allowed VLAN configuration to take those away. The .1, 802.1q encapsulation is the protocol that we're going to use at layer 2 for our encapsulation. It's a standard that supports VLANs in an Ethernet based network, assigns the VLAN identification information down here. We have two of them, ISL, and I don't know that you're ever going to be asked an ISL question. ISL inter-switch link protocol uses a 26-byte, as the slides next, a 26-byte header on it. It is a Cisco proprietary. 802.1q encapsulation is the standard which is used, and we've been talking about that we add the information, the trunking information before it goes into the switch and then take it out at the other end. Because if we didn't strip it out before it's forwarded to the devices on the VLAN, then we're going to wind up with a non-standard frame, and the machines, the servers, the workstations, the printers aren't going to know what to do with it. So it gets put in, the .1q gets put in as it leaves the switch, and then it gets stripped out as it goes away from the switch. Newer Cisco switches and other OEM switches use the .1q for tagging. ISL Cisco proprietary, yes, the newer ones, and the I was going to say, actually, I haven't seen one in a switch for a long time. Maybe 2500s were the last ones that probably had that the ISL available. I don't think you'll see it in anything that's probably been made in the last 10 years. But ISL, Cisco proprietary, has a the ISL and its headers here. We have 40 bits, 4 bits, 4 bits, 48 bits, and then we get the information in here. But it has a header in it, and it doesn't insert the tag in the middle of the frame like .1Q. Provides VLAN capabilities, full wire speed, operates in a point-to-point environment, can support up to 1,000 VLANs. It may need to find many logical networks that are necessary for your environment, but again, you're probably not going to see it. You just need to know that it existed at one time. Access ports, one VLAN. I think we probably beat that one into submission. One VLAN configured per interface unless we have voice VLAN, in which case we can have the voice VLAN as well as the data VLAN attached to it. And then the trunk ports carry traffic for multiple VLANs over a single link. It allows us to communicate over between multiple VLANs. What it really does is gives us a whole lot of flexibility. We can have, and one of those early slides showed, we can have users in different VLANs, maybe on different floors of a building, maybe in different buildings, in different rooms, and they communicate with each other as long as we have trunk ports, because the trunk port's going to carry the traffic for all the VLANs that are allowed on it, and by default all the VLANs are allowed. If you want to take some off, you can. Pruning is a term that you'll hear. Pruning happens if further down, if we enable pruning and maybe we have on the 5th floor we only have VLANs 1 and no 1, but say 20 and 30, and on the others we have maybe 20, 30, and 50, then there's no reason to send the 50 information to the 5th floor because there's nobody using it there. Trunks carry the traffic of multiple VLANs over a single link. We've talked about that, hopefully seen that, do some labs to configure that. A trunk port can carry traffic simultaneously for several VLANs. It can have 2 or more VLANs configured on the Ethernet interface, the trunk port itself. And then we have the Ethernet access ports and trunk ports, switch port mode, trunk switch port mode access for these things. Trunking, also VLAN trunking, interconnected ports to transmit and receive frames in more than one VLAN over a single physical interface. And again, it would do that by adding a shim basically in the middle of the frame that tells the system that this frame is a member of a particular VLAN. When it gets to the switch at the other end, the switch sends it to the VLAN that's in the .1Q encapsulation and in the tag, and then strips that tag out. So trunking allows us again to go VLAN 3 through the trunk ports to all of the VLAN 3s, and this doesn't have a whole lot of them on it. VLAN 1, yeah, not a big deal. We're all VLAN 1 over here. VLAN 2, actually, all of them would have VLAN 1. They may not have any switch ports on it, but they would all have VLAN 1 because it's the default VLAN. The trunking modes, we've kind of talked about. The default trunk on the older switches is dynamic. Desirable. Dynamic, they're all dynamic to start with. The newer switches is dynamic auto, and the advantage here is in the auto, dynamic auto, and dynamic auto is going to be an access port. It's not going to automatically become a trunk. Then dynamic desirable says, I want to be a trunk. The auto says, you ask, I'll be a trunk port. So the desirable in the auto is a trunk. If we use the switch port mode trunk command, it will become a trunk because it says, I want to be a trunk. So the auto says, okay, will become a trunk port. If it's an access port, it remains an access. Desirable, all of these down here in the access remain an access unless we give the switch port mode trunk command on one and the switch port mode access command on the other one. Because limited connectivity probably going to put it into an error disable mode. Trunk port, trunk, if we give the switch port mode trunk, it's going to negotiate with both of the dynamic capabilities and become a trunk port. Again, if it's access, each of them is going to be limited connectivity. Dynamic desirable, with the autos trunk, 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 the only time it's not going to become a trunk port with the desirable is going to be if the other one is configured as an access port. Desirable says, I want to negotiate. The access port says, I'm not going to negotiate, I'm an access port. You can also configure these things as a non-negotiate. Auto and auto is going to be an access, so if it's desirable or a trunk, it's going to become a trunk port. But those are the things, and that is one that you probably ought to have some idea of how those things work in becoming trunk ports. Dynamic trunking protocol, DTP, is what we just did. On. Trunk is on. Auto desirable is a trunk. This is the same things that we just looked at in the other one. The dynamic trunking protocol, Cisco proprietary, between the two devices, manages the negotiation, supports auto negotiation of both ISL and 802.1q if you have a switch that has ISL capability and you configure it. Dynamic trunking protocol is a second generation that allows the catalyst switches to negotiate whether to use the .1q encapsulation. If you have and the labs all say, oh, you've got to specify the encapsulation protocol, and the answer is maybe. If it's the only encapsulation protocol on the device, then you're not going to have to specify it. When I use packet tracer, if I use layer 2 switches, I don't have to do anything. I don't have to say anything. If I use a layer 3 switch, since it can have other encapsulation protocols, I have to specify the layer 2 encapsulation before I can make it a trunk port. VLAN trunking protocol, VTP, is to manage all configured VLANs across a switch. Administrator to add, delete, and rename VLANs, which is what I was trying to do earlier. We looked at this earlier. We had the server, the client, and the transparent. The server saved in NVRAM. We can save the configuration. The client configuration is not saved in NVRAM, and then the transparent configuration saved in NVRAM. A server can send configurations, create VLANs, send them to a client. A transparent device can create VLANs on it and they're not sent anywhere. The server, create them, send them to the client. We still have to add the ports to it. We have to use the access ports or switch port, access VLAN, whatever. Server mode, create, modify, delete VLANs, specify configuration parameters for the entire domain. The VTP server mode is the default mode. When we make a switch, it is automatically a server, and we can make changes to it. Client mode, but the client cannot, VLANs can't be created. Showed that earlier on that we tried to do it, says you can't do that. If I really wanted to do it on that switch, all I had to do was go in and change its mode to server, and I could do that. Transparent mode doesn't participate in the VLAN trunking protocol, and that's what I was trying to show in that when I finally got it to work on the packet tracer, that I could create the VLAN on the server machine, go back to that, create the VLAN on the server machine here, the server machine, and send it through the transparent switch to the client over here. One of the other things that becomes important, VTP status is the configuration revision number. This says 6. And when I go to the server here, hopefully it's going to be the same. Show VTP status. It's 6. This says how many changes have been made. When I go to the transparent, show VTP status, it's 0 because it's not sending updates. The reason I wanted to show that is, let's say you have a situation that a switch goes down. And you say, oh, we've got a switch laying around that we can use until Cisco sends us a new one that's in the lab. Let's just put it in. And people have been playing with it. It may have 12 or 14 VLANs. And it may have a configuration revision number of 600, where your other switches have a configuration revision number of 150. When you plug that new switch into your system, says all the other switches say, oh, configuration revision number of 600. I should update. So all of those VLANs are going to be put on the other switches. The way that you can make the configuration revision number by if you just delete the VLANs, it's still going to be there, is put it into transparent mode before you put it into your network. It'll bring the configuration revision number down to 0, so it won't update the rest of your system. .1Q encapsulation. We've looked at some of this before. The standard, we have the preamble, start frame delimiter, destination MAC, source MAC, type or length, and then the packet and the padding if we need it in the frame check sequence. The .1Q field, 3 bits for user priority, 1 bit for the drop eligible, and you notice that this has changed names from canonical format identifier to drop eligible information on this, and then 12 bits for the VLAN ID go into the shim, which goes into the middle of the tag control information here, which goes into the middle of the Ethernet frame. Different versions of the VLAN trunking protocol. One messaging protocol developed by Cisco. Changes made into the VLAN are documented as VTP configurations. Main function is to advertise the switching information, the VLAN trunking protocol, and hopefully we saw that. They had to be in the same domain, and they will share the information. We can configure them centrally as far as making the VLANs. We can't centrally add the ports to them. They have to be done on the individual switches. Main functions to advertise the switching information and configuration changes. Eliminates hassles involved in porting the same VLAN to another network which is managed by different switches. So we can send the VLANs to all of the switches that are in that particular domain. Manage them as a group, and then VTP1 transparent network device inspects the messages for domain name and version. And you notice that we'll go back to these, even in Packet Tracer, we're in VTP version 2. So you're probably, again, this is one of the things that you're probably not going to see VTP version 1, but it does inspect the network devices to be sure that the domain name and version is correct, and forwards it only when the version and the domain name match. Version 2 supports all the features of version 1, some additional. It's got token ring support, unrecognized type length value support, configuration changes. A VTP server or client transmits configuration changes to its other trunks, include even TLVs that the VTP server or the client is not able to parse. Forwards the messages in transparent mode without checking the version number, so we don't have to worry about the restriction that version 1 had. And then the consistency checks such as VLAN names and values perform only on new information specified through the command line interface or the SNMP information in the configurations themselves. So now we're up to some